you. Okay, brother. Assalamu alaikum. So today
Alaikum
we are
assalam wa
going to
rahmatullah.
today we are going to discuss the last chapter of physics 1. So this will be the last chapter, inshallah. After that, we have some times, so we can just convert that lab for some discussion. Maybe we will get 1 or 2 periods as the revision lab, revision class. By the time, if you have any doubts, you can just ask your doubts in the classroom itself. Okay. So the title of the chapter is Oscillations. It's with in our day-to-day life we come across these oscillations. Am I right? So if you just see this slide, what is written for the oscillation? Any motion that is repeated in equal interval of time is called periodic oscillation. For example, you can just see here the children is playing a swing in the children's park. So what will happen? He will go here and come back. He will go and come back. That means at a regular interval of time, he just oscillate. Am I right? His motion is repeated. Am I right?
Yes, you're right.
Yes, teacher.
For example, you can see when you just suspend any masses in the one end of the spring, and if you just attach the another end of the spring to the wall, when you just drag to some certain level, when you leave, what will happen? It will be oscillate up and down. Am I right?
Yes.
For example, you can take an example of our own body. You can just see our heartbeat. When you just go to the hospital, you can just take your heart report. The peak will be coming like this. Am I right? Have you ever noticed this?
Yes.
Our heartbeat will be exactly repeated in the regular interval of time. So that means you can see at regular interval of time, your peak will be coming here. For example, based on the diagram. Likewise, you can take an example of your eyes. Your eyes are blinking. Am I right? Your eyes are blinking at a regular interval of time. So whatever the things which will be repeated at equal interval of time, then you have to say that is called as periodic oscillation. If the periodic variations of the physical quantity over the time has the shape of sine or cosine function. So brother, here the oscillation will be represented either in terms of sine wave or cosine wave. You can see the picture here. I attached one end of the spring to the wall. So this is my spring. I attached one end of the spring to the wall, and another end I connected with a pin. So here I attached one pin, and here I have a paper which will be rolling. So what will happen when I just drag this pen to certain displacement level? What will happen after I leave? The spring will be oscillating here and here. Am I right? So it will be go back, going and coming back, going and coming back. Am I right? Am I right or not?
Yes, teacher. Yes, teacher.
Yes.
So when it will be going and coming back, you can see we attached one pen here. We attached one pen here. What will happen? The pen will make a waveform. Am I right? It will be exactly registered the wave function, registered the wave function on the rolling paper. Am I right?
Yes, you're right. Yes.
So your oscillation, it's your periodic oscillation is either represented in the form of sine wave function or cosine wave function. So we can say this is a cosine function. Am I right or not? So you have to register the waveform either in sine wave function or cosine function, and that type of motion is called as simple harmonic motion. You already did the experiment 10 last week. Simple pendulum. Simple pendulum is a good example for simple harmonic motion. When you just take this pendulum, take this bobs to certain height, when you just leave, what will happen? It will be oscillating. Am I right or not? At a regular interval of time, it will be going and come back. So that is that topic is comes under simple harmonic motion. Clear? Now, what is simple harmonic motion? When you just see this picture, when you've just registered, when you just recorded the waveform on the paper, you can see here, this is my equilibrium condition, and it will be go to some maximum displacement level in the top as well as in the bottom. Am I right?
Yes, you're right.
So the maximum exerted portion from the equilibrium condition is called as amplitude. So if you just take a waveforms, for example, this is my waveform. Now you can see what is my amplitude? This is my amplitude. What is this? This is also my amplitude. That means if you take one wave, you will have 2 times of amplitude. Am I right?
Yes, you're right.
So then when you just come for the definition for the simple harmonic motion, the definition for the simple harmonic motion is given here. What is written here? The motion that follows the repetitive pattern. That means it will be oscillating. So repetitive function will be happen on the object. So caused by the restoring force. For example, you can get the example of the spring. I have the spring, and the spring is connected to one end of the wall, and another end of the spring is connected with a small mass. I just drag the spring to certain displacement level d naught. After I leave, what will happen? It will be oscillating up and down. So that means it will be happening a regular interval of time. At the same time, the spring will have the restoring force. Am I right or not? So the restoring force make the object to move up and down. Clear?
Clear. Doctors,
Oh,
do,
yes.
do we will study with 1 minute with 1 minute, doctors,
Yes, yes.
wavelength?
Yes.
Do we will study?
Yes, we are going to, because in this chapter we are going to study some basic parameters. If you have the waveform, what are the basic parameters we have in the wave? So out of this parameter, the first parameter is the amplitude. What is our amplitude from this? So our amplitude is the maximum exerted portion from the equilibrium. So that means this is our amplitude region. Am I right? So this is our
Yes.
first parameter if you have the waveform. So later on we are going to study what is wavelength, what is time period, what is the angular frequency, what is the frequency. So we are going to study it one by one right now. Clear?
Yes.
Okay. Now you can just see this picture, brother. Here you can see I just pushed the spring to some certain height level. So that means it is the maximum portion. Am I right? It is the maximum height. Am I right or not?
Yes, you're right.
So you can just see this is my second position of the spring. This is my third position of the spring. This is my fourth position of the spring. This is my fifth position of the spring. So now you can see here, I have two top layers. One is in the top, one is in the bottom. So if you just consider this is my equilibrium line. So this is your amplitude. Am I right? Am I right or not?
Yes, you're right. You're right.
And this is also your amplitude. Now, brother, you have to keep this information in your mind. When the object reaches to the maximum position, what is the speed in this position? What is the speed in this position? When the
And the
object
top
reaches to the
0.
maximum level, when the object reaches the maximum level, your speed at that position will be 0, because after that the object will not go up level. Am I right or not?
Yes,
So this
you're
is the
right.
maximum level. After that, it will not move. That means in this position, your speed will be 0. That means once the speed becomes 0, your acceleration is going to start in this direction. Am I right?
Yes, you're right.
So at the maximum level,
Yes.
your speed will be 0. At the center, your speed is maximum. So whenever you just, when the object reaches the maximum level, your speed will be 0 at the top as well as in the bottom. But in the middle, your speed will be the maximum. So you have to keep this information. When the object reaches the maximum level, your speed will be 0. Your acceleration is going to increase. Clear? At the same time, when the object comes to the middle level, your v becomes maximum and your acceleration becomes 0. Keep this information always in your mind. Understand?
Okay. Doctors,
For example,
Minas,
okay. Just a minute. I can just a minute. I can just put one more slides, and I can explain the concept based on your simple pendulum. By that time, you will get a clear idea. For example, this is your simple pendulum. In your lab, you already finished this experiment. Am I right? So this is my simple pendulum equilibrium condition. Am I right? This is my
yes, you're
bob. This is my bob, and you just move with a small angle. So this is my angle theta. Am I right? And here you have the bob. Brother, when you just oscillate, when you just drag this bob to certain level with respect to some theta, what is the speed here? What is the speed here? This is the maximum position. Am I right? What is the speed here?
Yes, you're right.
0.
Zero.
Zero.
Likewise, when the bob comes here, what is the speed here?
0.
So now, when the bobs moves in this direction, its acceleration is going to increase. Am I right?
Yes.
When
Yes,
the
you're right.
object comes to this point, your speed is maximum. Am I right?
Yes.
When the object reaches this point, so you can just keep the point. This is my first point, this is my second, and this is my third. So the point 1 and 3, your speed is 0, and when the point comes to the level of 2, your speed becomes maximum. Am I right?
Yes, you're right.
When the speed becomes maximum, what is your acceleration in this region?
0.
0.
0. What is your acceleration in this region?
Increase.
Increase.
Maximum. Likewise, what is your acceleration in this region? It is maximum. So when you just keep this information in your mind, solving the problem from this chapter will be very easy. Clear?
Almost opposite, doctor, right?
Yes, of course, almost opposite. When the object reaches the maximum displacement level, your speed becomes 0 at this position. But your acceleration is going to increase. For example, you can see this bob. When the bob reaches to this third point, your speed becomes 0. And after that, what will happen? Your acceleration will be in this direction. Am I right?
Yes, which mean increase.
So your acceleration is going to increase. Am I right or not?
Yes, you're right.
So keep this point in your mind. Understand? So when you just come for the equation, the displacement of the equation is given in this way. So what is written here? X of t is my displacement equation. And here we have some parameters. When you want to explain the concept of the wave equation, we have some parameters. My displacement of the equation x of t, which is equal to my amplitude. What is my xm here? My xm is the
Amplitude.
What is my xm here? Amplitude. That means you can just see from this picture. From this picture, this is my amplitude. Am I right? So this is my xm. Clear?
Yes, clear.
And then you have to represent the equation in terms of sine wave or cosine wave. Am I right? Just before we study. Am I right or not?
Yes, you're right.
And when the equation, when you have the wave equation, the most important thing is the phase region. So the phase is the combination of angular frequency, and the time is very, very important, because based on the time, the wave equation is very, very important. And also we have the phase constant, because we have 4 quadrants. Am I right or not? This is 0, this is 90, this is 270, this is 180, this is 270, and this is 360. Am I right or not?
Yes, you're right.
So this quadrant tells you about this angle phi. So when the object is exactly in this position, your phase is equal to 0. Am I right?
Yes, you're right.
So when you just come for the wave equation, this equation is very, very important, because when you are about to solve the problem from this chapter, you have to know the basic equation for the wave. So what is the basic equation? You have to just please memorize this equation. What is our equation? X of t is my displacement of the equation, which is displacement of the wave equation in terms of time, which is equal to my amplitude xm, and the waveform is in terms of cosine wave function, which has the wave constant, which is nothing but omega t plus phi, where omega is the angular frequency, where t is the time, where angle phi is the my phase constant or phase angle, and xm is the amplitude. So in this chapter, this equation is very, very important for solving some question. Clear?
Clear.
Yes, doctor.
Now let's come for the formula. We already studied this formula. When you have the wave, it must have the frequency. Am I right? We already studied the formula. My frequency, which is nothing but 1 over time period. My time period, which is nothing but 1 over frequency. We already studied this formula in chapter number 4, when you study the concept of the uniformly circular motion. Am I right? Am I right or not? Have you
Yes.
studied this
Yes,
rule?
you are right, teacher.
Yes.
Yes. So,
Doctor.
what is the definition for the time period? Yes.
In chapter 4, we don't study this formula.
Chapter 4 or chapter 6 you will study it. You can just go and refer. When you study the concept of the uniformly circular motion, we use this formula. We use this formula.
Oh. Okay.
Or you can say, no, I can just show you.
I don't remember we studied same formula.
Chapter 4 or chapter 6 this time? It's chapter 4. What happened to my file? What is this? What is this equation?
2 pi r over v.
What is 2 pi r? We are just using our basic equation, time which is equal to distance over speed. Am I right?
Yes, you're right.
Your distance over speed is our frequency. So the basic formula is here. So we have to derive this formula from our basic equation. Clear? This is the
Clear.
time period.
Oh, okay. Thank you, Victor. I got this.
Yeah. Okay. Now, if you have the frequency, what is the definition for the time period? It is a time required for one complete motional cycle. What is our one complete motional cycle? For example, if you take the waveform, this is my one wave. Am I right? Am I right?
Yes,
Yes.
you're right.
Of course, teacher, you are right.
It will be start from here, it will be end here. So you have one crust region, one trough region. So the crust is the top, one trough is the bottom. So this is one complete wave. So if you want to calculate the time period, you have to complete one cycle. Brother, do you remember the experiment number 10? You just take your bob to certain level with respect to some angle and you leave. How to calculate the time taken for 5 oscillation? One complete oscillation is nothing but it will be going and coming back. Am I right?
Yes.
Yes, you're right.
It will be going. For example, when you just drag the bob, it will be going and coming. This is counted as one complete cycle. Am I right? This one complete cycle is nothing but the time period. Am I right?
Right.
So we are just having the definition for the time period is nothing but it's a time required for one complete cycle. So what is the definition for the frequency? The number of motion of the cycles per seconds. 1 second, in 4 seconds, how many cycles would be happen? So we have some example here. So I will just give some example. By the time you will get a clear picture how to calculate the frequency. Now, when you have the waveform, just before we studied this equation, we have this omega. Am I right? We have this omega is a wave angular frequency. It is not an angular velocity. It is an angular frequency. So when you just come for the concept of the wave equation, you have to use this omega as an angular frequency. Brother, don't think this is our angular velocity. This is your angular frequency. Angular frequency omega, which is equal to 2 pi f. So what is the relations between your linear frequency and the angular frequency? This is my angular frequency. This f is my linear frequency. So what is the basic relation? My relation for the angular frequency and the linear frequency is omega, which is equal to 2 pi f. What is my f? My f is 1 over t. So what you will get? Omega, which is equal to 2 pi over t. Clear? So if you have any questions for calculating the angular frequency, if the time period is given, you can easily calculate its angular frequency. Or if the frequency is given, you can easily calculate its angular frequency. Am I right? So its unit is
Yes, sir.
radian per second. Clear?
Clear.
Now, how to calculate the maximum speed? How to calculate the maximum speed? Just before I told you, what is our wave equation, brother? Based on displacement. Could you please recall the equation? What is our equation? X of t, which is equal to xm, this is my amplitude, cosine function, omega t plus angle, phase angle. Am I right? So this is my
Yes, you're right.
displacement equation. How to find the velocity, brother? What is the definition for velocity? Instantaneous velocity.
Time over
Time.
My instantaneous velocity, which is equal to dx over dt. Am I right?
Of what?
Yes.
Yes, teacher.
Now I am going to apply this rule. I am going to apply this rule in this equation to find our velocity equation. So how you have to do, my dear brother, listen carefully. V of t, that means the velocity in terms of time, which is equal to my displacement over time differentiation. So my dear, listen carefully. That means d of x of t divided by dt. Am I right?
Yes, you're right.
So I'm going to differentiate this equation with respect to time. So this is my constant amplitude. I'm going to write my constant as it is. What is my amplitude? Xm. If you differentiate this cosine, what you will get, brother? If you differentiate this cosine, what you will get?
Sine, of course.
Minus
Minus
sign.
sine, minus, yeah.
Ah, so differentiation of the cosine is minus sine. So I have to write minus sine. Clear? Clear? And then the sine is together with the phase. So what is my phase? My phase is omega t plus phi. Am I right?
Yes, you're right.
right.
And also here the omega t is connected with the time. So if I just differentiate this term with respect to time, I will get omega. Am I right?
Yes, you're right. Of course.
So what is remaining? Minus sine xm omega sine omega t plus phi. Am I right? This is my equation. Am I right?
Yes, you're right.
So
Okay, but
I can
why it's not going?
What,
If you make differentiate of theta,
differentiation of the theta.
yeah, it will be 1.
Wait. We are differentiating with respect to time, not theta.
Yeah, I know that. But theta, we just put it like this.
My dear, could you please tell me what is our equation in terms of displacement? X of t, which is equal to exm is my amplitude,
Sine,
cosine.
double
This is my
T.
phase. Brother, whenever you are writing the cosine function, you have to write with this.
Oh, yes. I got it.
You have to write with this. Okay, now listen carefully. I am going to differentiate this equation with respect to
Time. Yeah. I got it,
time.
Doctor.
Okay, so V of t, which is equal to my dx of t over dt. Am I right? Now listen carefully. Xm is the constant. That means my amplitude. I can just write xm. Differentiation of this cosine, what you will get? Minus
Minus
sine omega t plus phi. Am I right?
Yes, you're right. Of course.
And then if you differentiate this omega t, what you will get? You will get only omega.
Yes, of course.
You can't, because in this angle phi there is no time, so you cannot, if you cannot be able to differentiate this. Am I right?
Yeah, of course. Yeah, I got
Okay,
it.
now what is remaining? What is remaining? Minus sign, I can take it in front. Omega I can take. So this is my xm sine omega t plus phi. Am I right?
Yes, you're right.
Am I right? So this is my speed equation. Now, if you want to get the maximum speed, so this is my phase constant. So if I just consider this phase as 1, what is my maximum speed? My V maximum speed, which is nothing but omega multiplied by xm.
Yes, of course.
Am I right? Because why I just take the negative? Because I'm considering this is my maximum speed. What is speed? What is speed? Speed is a scalar quantity. You have to consider only the magnitude. Am I right? So magnitude of this velocity gives you only the positive value, absolute value. Am I right?
Yes, you're right. Doctor,
Likewise, yes.
sine WT plus
It is not
theta.
W. It is not W. It is omega, angular frequency.
Omega,
Sine
yeah.
omega. Brother, when you just come for this quadrant, my dear, listen carefully. When you come for this quadrant, this is your 0. Am I right? This is your 90. This is your 180. This is your 270. This is your 360. When the object is exactly here, what is your phase angle, brother?
I got it. It will be
So
0.
I can consider this 0 for the phase angle, and then the sine of omega t I can consider as 1. Clear?
Clear.
Clear?
Clear.
Clear.
Okay.
Or
Likewise,
0.
let's what?
Or omega 0, and it
My
can.
dear, my dear, I just substitute only the angle is 0. Here it is plus sign.
Okay.
If everything is become 0, then your speed will also be 0. Am I right?
Yes, of course.
So it is meaningless. Okay, let's become for the acceleration. What is the formula for instantaneous acceleration? What is the formula for instantaneous acceleration? My instantaneous acceleration is dv over dt. Am I right?
dv over dt. Yes.
Okay. What is my velocity equation? My dear, listen carefully. My velocity equation is minus omega xm sine omega t plus phi. This is our speed equation. Am I right? Velocity equation. Am I right?
Just rewrite the W in
Could you
terms
please
of
could you please differentiate this equation one more time with respect to time? You will get acceleration. Am I right? Okay, listen carefully. Minus, I can write minus as it is. Clear?
clear.
Xm omega, I can write as it is. Clear?
Clear.
Clear.
What is the difference? What is the differentiation of the sign?
Cosine.
Cosine omega t plus phi. If you differentiate this omega t one more time, you will get 1 more omega. Am I right?
Omega.
Right.
So what is remaining? Minus omega square xm cosine of omega t plus phase angle. Am I right or not?
Yes, you're right. Doctor, you don't
So
write
now,
anything.
don't write anything means? I couldn't get you. What you're saying?
No, it's clear. My screen, it's off. No, it's good.
Oh,
Ah.
maybe based on the low internet, the internet speed is bad. Okay,
Yeah.
now what is here, brother? My acceleration, which is equal to negative of omega square, and this is my xm cosine of, my dear, listen carefully, omega t plus phi. Am I right? What is this, brother?
XT.
This is my xt. Am I right? So how I can
Yes.
write? I can write minus omega square of x of t. So what is my maximum acceleration? My magnitude of the maximum acceleration is only the maximum of the amplitude. Am I right? So I can write omega square of xm. Clear? This is my maximum acceleration in terms of amplitude. The amplitude is very, very important in the phase equation, in the wave equation. Clear?
Okay,
Clear.
Doctor,
Clear.
so when X
Yes, teacher,
maximum,
clear.
it will
What
be
was
0 or what?
My dear, still you are get confused about this. Omega t plus phase angle only 0. But the sine of omega t is very, very important for the wave equation because this is your angular frequency. This is a time parameter.
Yeah.
Clear?
Yeah, I got it. Yeah. Clear.
But we are not pointing out this because all this equation is based on the amplitude. Am I right?
Yes, you're right.
That's what I just write minus omega square xm. So when you just see the previous equation, you can just see the previous equation. I forgot to remove this because this is an old slide. I see here, this is my magnitude of the velocity, which is nothing but omega xm. And the next slide, I can just give the acceleration. What is my acceleration? My acceleration is xm omega square. The same equations we have right now.
Okay.
If you take the magnitude, what you will get? My magnitude of acceleration, which is equal to omega square of xm. Am I right?
Yes, you're right.
So that formula is written here. Understand?
Understand.
Okay. Could you please answer this question? Could you please answer this question? With this question, inshallah, we will conclude the session. We will just see the remaining thing in the next class. Okay?
Okay.
Okay, could you please read the question? I have the loudspeaker box. I have the loudspeaker box because in our home we are using this loudspeaker box. Am I right? Am I right or
Yes,
not? Okay.
Yes.
Here you can see one black color. This is called as diaphragm. When you just give more sound, this will be vibrate. Am I right? Have you noticed these things? This will be vibrate.
Yes. Yes.
So it will be vibrate like this. Am I right? So I just magnify the diaphragm region here. So how it will be vibrate? It will be going to maximum. It will be coming back to the maximum. That means this is my equilibrium position. It will, while it vibrate, this is my amplitude. This is also my amplitude. Am I right?
yes,
Yes, teacher.
Yes.
Okay. So the diaphragm of the loudspeaker moves back and forth in the simple harmonic motion to create the sound as shown in the figure. The frequency of the motion is f, which is equal to 1 kilohertz. So what is the frequency, brother? My frequency is 1 kilohertz. What is the meaning for kilo? 1 multiplied by 10 to the power of 3 hertz. Am I right?
Right.
Yes.
And what is its amplitude? Xm value is given. What is your amplitude? 0.2 millimeter. That means 0.2 multiplied by 10 to the power of minus 3
Minus
meters.
3.
Am I right?
Yes.
Okay. Now, could you please calculate what is your maximum speed? What is the formula for maximum speed? The formula for the maximum speed, which is equal to omega xm. Am I right?
Yes.
yes, you are right.
What is the formula? What is the formula for omega? Omega, which is equal to 2 pi f. Just before we studied. Am I right?
Yes, you are right.
So substitute the value V max, which is equal to 2 pi f multiplied by xm, and 2 multiplied by 3.14. And what is your frequency? It is already given in the question. What is that value? 1 multiplied by 10 to the power of 3. And what is your amplitude? My amplitude is 0.2 multiplied by 10 to the power of 3. You will get the maximum speed. Am I right?
Yes, you are
Right.
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 Okay. Now, could you please tell me what is the answer for the second question? The second question is the theoretical question. What is given in the second question?
What is the motion does this maximum speed occur?
Okay, you can see this magnification part. Okay, brother, you can see this magnification part where your speed will be maximum. Your speed will be maximum here or here or here.
Left and right.
In the middle.
My dear,
In the middle. In
my
the
dear,
middle.
In the middle, of course.
before you answer, read the question very carefully. Just before I told you, when it comes to the maximum left hand side and the right hand side, your speed is 0 here. Am I right?
Right.
What is your
Yes,
speed at the
left
middle?
hand.
At the middle, your speed is maximum. Am I right?
Yes, you're right.
Yes, of course.
So
Yes.
you have to write here at the middle portion, my speed is maximum. Am I right?
Yes,
Yes.
you are right.
Okay. What is the answer for the third question? What is the maximum acceleration? What is the formula for maximum acceleration? The maximum acceleration is omega square multiplied by your amplitude. Am I right?
Yes, you are
Yes.
right.
So 2 pi f the whole square multiplied by xm. Frequency is given in the question, amplitude is given in the question. You can easily find your acceleration. Am I right?
Yes, you're right.
Yes.
Of course.
Okay. What should be the answer for the last question? It is a theory question. Just tell me the
Left
acceleration.
and right. Left and right.
Your acceleration will be maximum here and the maximum here. But what should be your acceleration at the center? It is
0.
The max.
Clear. Clear.
Clear.
Clear.
So likewise, the question will be coming from this chapter. Sometimes the diagram will be given. Sometimes the information will be given clearly in the question. So you have to read the question very carefully before you answer. Understand?
Understand?
Okay. Let's we come for this. We will just conclude by this slide. Right now the time is exactly 8:20. This question is also very, very easy. And here the diagram is given. Could you please read the question and give the answer? And 0.8 kilogram object is attached to one end of the spring as shown in the figure, and the system is set into the simple harmonic motion. So simple harmonic motion means the spring will be making this type of wave equation. Am I right?
Yes, you're right.
Yes, Doctor.
The displacement x of the object as the function of time is shown in the diagram. So first question, what should be the amplitude of the motion? Brother, diagram is given here. My dear, listen carefully. This is my origin and this is my 0.080 and the time, maximum time is 4. Am I right?
Yes, you're right.
Okay. What should be the amplitude from this diagram?
0.08.
0.08.
Very good. So the maximum displacement from the zero origin is my amplitude. So what is the answer for the first question? 0.080
0.08
unit. The unit is very, very important. What's the unit?
meter.
Okay.
Meter.
Now, what is your angular frequency? What is your angular frequency? The angular frequency omega, which is equal to 2 pi over t. Am I right?
Yes, you are right.
What is my t? My t is nothing but one complete wave. This is my one complete wave. Am I right?
Yes,
Right.
you're right.
So what is my time period?
4 seconds.
4 seconds.
So 2 pi over 4, which gives your angular frequency. Am I right?
Yes, which is
Okay.
1.5.
Pi over 2.
Oh, yes, you can just write, substitute the value, get the answer. Clear?
Yes.
Clear.
Okay. What should be the answer for the third question? The speed of the object at t is equal to 1. Brother, what should be the speed here?
Zero, because it's the max.
No,
Here and here, your speed is 0. Am I right? So
Right.
when the
Yes.
object comes to 1 second, my speed is 0 in this position. So what should be the answer here?
0.
Okay. What should be the magnitude of the object acceleration at a t is equal to 1 second? So what should be your
Maximum.
acceleration here? What should be your
Maximum.
acceleration here?
Maximum.
Maximum. So what is your acceleration formula? My acceleration formula, maximum is equal to omega
W
square
T.
multiplied by xm. Am I right?
Right.
Maximum, yeah.
Omega you got from the second question. Am I right?
Right.
Yes, you're
Yes.
right.
And your amplitude is given from the picture as 0.080. When you substitute, your maximum acceleration will be getting here. Am I right?
Yes, you're right.
Yes.
Right.
That's it. So likewise, the question will be coming from this chapter. Clear?
Clear. Thank you, Doctor.
Clear, bro?
Clear.
Brother, inshallah, we have only 2 more topics. Inshallah, we will discuss the topic, inshallah, coming Wednesday. Clear?
Clear.
Clear.
And
Inshallah.
problem
If you
to
have
solve,
any, yes, brother?
problem to solve, we solve next week.
No. Next week I will complete the chapter. Inshallah, week number 15, Sunday, I will complete the chapter from Physics 1.
Okay.
Clear? Week number 15, we have Sunday class. Sunday, I will complete the entire chapters of this 15, and by that, you will complete the full portion of the Physics 1.
Okay, thank you, Doctor.
Clear? Understand?
Understand.
Any other,
Yes.
any other question? Any other question?
No, thank you, Doctor.
Is it clear?
Doctor.
Brother, if you have any doubts, better please feel free to talk with me. Understand?
Yes, doctor.
Okay.
And please, brother, till you have maybe 2 more weeks, we have the discussion class. Only 1 or 2 students, maybe sometimes Mr. Hassan is coming, sometimes Mr. Muhammad is coming for asking the question, and sometimes Mr. Abdullah is coming. What about other student? Huh? So far, I just saw only these 3 students in the discussion class. What about others? Huh? My dear.
Yes, teacher. Yes.
Okay, please listen carefully. So we have 2 more weeks for your final exam. Please, if you have any doubts, we have the discussion class tomorrow. If you have any doubts in the previous chapters, you can come and ask your question. Okay?
Okay, doctor.
Yes.
Yes, sir.
What about the final? It will be in week 16 or 17?
My dear, I think mostly your exam for the physics exam will be in week number 17. I think so. I'm not sure because still we don't know the clear picture about the final exam schedule. Okay, so hopefully it will be in week number 17. But whatever it may be, we have to get ready from week number 16. Clear?
Clear.
Clear.
Doctor,
Clear.
I have a question.
Okay. The second thing, first of all, I finished, Mr. Abdullah. The
Okay.
second question, for your final exam, your theoretical question is objective, multiple choice question.
Oh, it's nice.
Okay.
Clear? Only the theoretical question, the first question of your paper. You are always, the first part will be is your theoretical question, knowledge-based question. And
How many
all
questions,
your
Doctor? Theory.
maybe 5 or 6 question will be there. I think so. Maybe 5 or 6 question will be there.
Okay. Yeah.
The remaining all the problems are numerical type question. So you have to write it clearly to get the answer. My dear, it's my kind request for all the students. Please write the formula. Try to work out with the formula. Try to substitute the value in the formula. Try to answer the question with the unit as well as its number. Okay. Don't forget to write the unit. Don't forget to write the formula. Don't try to give the direct answer. At least when you write something, even if your answer is wrong, we may consider the mark for your formula as well as your unit.
Okay.
Clear? So each
Clear.
and every mark from your final exam is very, very important for qualifying your physics 1 in final exam. Clear?
Clear.
Clear, Doctor.
So please follow my instruction. Your numerical, your theoretical question, all questions are multiple choice.
Doctor, how many question problem to solve in
Numerical.
yeah in
It's like,
exam?
maybe listen carefully. How many chapters we covered for after the quiz 2? From chapter number 9 to 15. Am I
6.
right?
Yes.
So 6 questions, 6 numerical question must be there. I hope so.
From
From,
each chapter.
Each chapters 1 3-mark question will be there. I'm sure, because then only we will get 30 marks. Am I right?
Yeah.
Yes.
Total
3
3
marks.
marks on
My
every
dear,
question.
every question has some subdivision, small question. Each question carries 1 mark.
Okay.
Total how much, doctors? Maybe how much question?
My dear, listen carefully. 22 marks comes from your numerical question. 6 marks comes from your theoretical question. So please prepare well from chapter number 9 to 15 first, and then once you complete your chapter from 9 to 15, please go back and revise your previous chapters. Clear?
Clear.
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 Clear. So possibilities are more. Out of 30, for sure, if you prepare from chapter number 9 to 15, for sure, you will get more than 15 marks.
Okay.
Clear?
Okay.
Clear. Thank you,
And
doctor.
the rest of the things in your hand. If you work hard, you will get more marks.
Inshallah.
Inshallah.
Clear? So don't worry, the
Clear.
question will be very easy, but please prepare well. Please prepare well. Don't get confused by yourself. It's my kind advice to each and everyone. Please solve the problems which we already discussed from the class. That will be quite enough for getting good marks. Similar type question will be in your exam paper. So please take a paper, try to work out each and every problems by yourself, and try to work out with your calculator. Try to take a practice with your calculator. That is very, very important. Okay?
Yes, of course.
That's it. Inshallah, today's session is over. Inshallah, we will see you on Wednesday class.
Okay.
Clear,
Teacher,
brother?
one last question,
Yes.
please.
Yes.
Is there any chance to change the appointment of the final exam?
You mean changing the schedule of your physics exam?
Yes, make it maybe
No,
after
no,
the
no,
calculus
it's
by
not.
2 days.
It's not. It's not possible. My dear, changing the exam date for physics or any subject, it's not possible, because when you are registering the course for this semester, you can see your final exam date. Am I right or not?
Yes.
So why you
I don't
registered?
know.
No, brother. Before, when you are about to register, for example, inshallah, semester 422 is there. Am I right? Next semester.
Yes.
When you are about to register your course, you can see your final exam date.
Uh-huh.
Clear? So when you frame the timetable for next semester, first we fix the exam date. That is very, very important. Then only we can avoid the conflict.
They now upload the next semester.
I think hopefully maybe this week or next week your online registration will start. I think so.
Oh, yeah.
So I wish you all the best. Inshallah, try to work hard. Still, we have 2 more weeks. Please prepare well. Understand?
Understand. Thank you,
I
Doctor.
understand, yes.
Doctor,
That's it.
I just have
Yes,
one
yes.
question.
Yes, yes.
Stress, it's equal to F over A, right?
Yes, yes, right.
And we consider A area,
Uh,
which mean
yeah, yeah.
square, the
Meter
units.
square.
And
Meter square.
yeah, meter square or inch square. When we have volume, doctors, it will be meter over 6.
You see my screen?
Yes.
Okay, just a minute. Just a minute. Stress formula F stress, which is equal to force per area. Am I right?
Yes, you're right.
So force will be given in the question. You can see the cross section. If the diameter is given, you can just see the diameter. If the diameter is given, the cross section area is circle. Am I right?
Yes, you're right.
From the diameter,
Okay,
you can
if it is
easily find the
volume,
area. What?
if it is volume,
Volume means volume information will be given.
okay, but the unit, it's meter over 6
Newton per meter square.
for the volume.
What is the formula for volume? It is bulk stress over bulk volume. Am I right?
Yes, you're right. But we consider it meter cube.
But you have to use the Pascal. How it becomes meter cube? How it becomes meter cube?
Oh, okay.
How you will get
I
the
got
meter cube? I can just go back to chapter 12. Just a minute. I will just go back to your chapter 12.